So as we take a look at this post again, it'll be broken into a couple of days during the final. But what we're going to do here, okay, for questions 1 and 2, use these two functions. And now we're going to use our function notation. Okay, so here's one of the changes that we've seen. G of x minus f of x just very simply means take my g of x function, x squared minus 2, and we're going to subtract our f of x function for x minus 3. And my job is to simplify. So when I'm looking at this, that minus is going to distribute to both of these terms. So nothing happens to the first one, really. I'm just going to take the parentheses off. And then this negative will distribute to the 4x and to the 3. And now we just put them in order from greatest degree, which would be the squared, and work our way down. And if we have like terms to boot, we get those in there. Nothing too shabby. The function notation, the of notation, has been something that was a little bit of a challenge earlier this year. Now I'm going to try something, so my apologies to those of you. Hang on here just a second. So, really? I just start. They're like, Harty, did you have like a power outage there? No, it just decided to turn back off again. Okay, now we're back. When we're doing this first, we always work from inside out. So in this case, my first job is to do g of 3. In other words, I'm going to take my g function, and I'm going to plug 3 in where x is at. So that would give me 3 squared minus 2. X out, 3 in. 3 squared is 9, minus 2 is 7. But I'm not done, because now that took care of part 1. Part 2 now becomes taking my f function with that answer. So there's my f function. Replace the x with the value in the parentheses. 4 times 7 is 28. Minus 3 is 25. And I get my answer. But you've got to do it in 2 pieces. If you don't do it in 2 pieces, it's not going to get you very far. Next one should be a familiar one. Identify the transformations, fancy way of saying shifts, for the following graph. So again, left, right in here. Opposite of what we would think. So left 6. And then my outside is my up and down. Minus means it's going to be down. Now, I will give one hint here. If you happen to forget that, if you would put this into your graphing calculator and graph it, you might be able to visually see it moved left and down. You might be able to get a hint that way if you happen to have a little bit of a brain cramp on that. And that happens sometimes. Identify the amplitude and period, okay? Amplitude, again, goes with our A value. But remember, if, for instance, we happen to make that negative on the actual test, amplitude's always positive still because it's a distance. My period is not my B value. Okay, my B value here is 2. But my period is found by doing 2 pi divided by B. 2 divided by 2 is 1 in this case, or just pi. If that was a bigger number than 2, we'd try to reduce the fraction down as best we can. Okay? But it's always 2 pi over b. Graphing 2 cycles of the function, which again means this one. So we're going to start with our traditional, we know we're starting at 0. Now this time we know our period, we already calculated it, it's pi. So we know this is going to be pi. Now this is where we've got to think a little bit. Okay? We are not going to have access to our card. Like, what? Okay? So this is where I remember back to what we talked about a bit yesterday. Where our pattern, when we're thinking about our base points, is 0, and then it goes up by 1/2 or 1 over 2 each time. So if I do 1 over 2, but I turn that into pi, so 1 over 2, 2 pi over 2, which would just be pi, 3 pi over 2. You notice I just keep adding 1 to the top. 1 over 2, 2 over 2, but we reduced it. 3 over 2, 4 over 2, which would be 2 pi. So you're like, okay, what good did that do me? Well, now since I know my b value is 2, what I can do is, remember, we multiply by the flip, the inverse of b. So we're going to multiply all of these by 1/2. So as I'm doing this, 0 times 1/2 is 0. Okay, that's fine. Pi times 1 is pi. 2 times 2 is 4. Pi times 1 is pi. And since I don't have a denominator there, that just stays as 2. 3 pi times 1 is 3 pi. 2 times 2 is 4. And then 2 times 1 is 2 pi over 2, which is pi. So we've got that first cycle ready. What we just did there is going to be the trickiest part. If you just remember your base values here, just are like 0, 1 over 2, 2 over 2, 3 over 2, 4 over 2. The rest of it won't be that bad. My amplitude is 5. Which means my minimum and maximum are 5 and -5. And now the only other thing I got to remember, one last thing to remember, with cosine, do I start at 0 or do I normally start at 1? Normally start at 1. So if that's true and my amplitude or my A is 5, I'm going to start at my max up at the top. Then we go to our midline, and our min, and our midline, and our max. Now that's one cycle, okay? I get my curve. Now for my second cycle, if I want to make the graph first, which isn't a terrible idea, I go, okay, I'm starting the same spot. I'm going back to 0, back to my minimum, back to 0, back to my max. Okay, so I've got my graphing part done. Now I just got to label these. And I could do it one of a couple of ways. If I just want to keep going with my pattern here, which is probably the best option. So I did 1 over 2, 2 over 2, 3 over 2, 4 over 2, 5 over 2. Let's even do this. 6 over 2, 7 over 2. Because I just keep adding that 1/2. 1 over 2, 2 over 2, 3 over 2, 4 over 2, 5, 6, 7, and 8. Okay, I'm just keeping on going, and I'm going to keep multiplying by the 1/2. Again, my 1 over b. So if I keep creating these, 5 times 1 is 5 pi. 2 times 2 is 4. If I try to reduce that in the calculator, I do a math enter, it doesn't get me anywhere. Now, this next one, 6 times 1 is 6. 2 times 2 is 4. Does 6 over 4 reduce? If you're not sure, this is one, and we'll show it on the calculator just to make sure that we're doing good things. So here I take a peek, and I go, okay, now it's 6 pi over 4. Don't put the pi in. 6 divided by 4, math, enter, which is 3 over 2. So this is 3 pi over 2. Now, would I mark it wrong if you put 6 pi over 4? It might be a slight, but it's not going to be a big deal. 7 pi times 1 is 7 pi. 2 times 2 is 4. And then 8 times 1 is 8 pi. 2 times 2 is 4. But what's 8 divided by 4? 2. Hi. You're like, woo, there's a lot of things going on. It all, let's be honest, it all comes back to just getting that down. Just keep increasing by 1 pi over 2, 2 pi over 2, 3 pi over 2, and just keep that pattern going. Everything else will build off of it. You don't have to do a lot of fancy stuff with those. If you need to, again, you'd write a couple of those down, you get a little extra practice. All right. What's that? Yep, halvesies would work as well. At a town with a large convention center, cost of the hotel room is increased 4.1% annually. If the average hotel room costs $39 in 1980 and this growth continues, create a function that models the exponential growth of the room price starting in 1980. Okay, so basically all they're telling us is plug in values for A and R. A is what I started with. Now, it does not mean when this is plus minus that I use both. It means, is it growth or decay? If it's growth, it goes up or plus. If it's decay, it would be minus, but it says growth. So I use plus. The 4.1% needs to be in its decimal form, and we've talked before about you need to divide that by 100 if you're not comfortable doing that. That is my function. However, this time, we are asked, what will the room cost in 2020? There's an additional question, which means I have a t-value now, but maybe not the t-value that you're thinking of. What would be my t-value in this case? Is it 2020? They're like, it must not be if he's asking. If we started in 1980, and it's now 2020, how many years later is that? 40. So my t-value is going to be 40. And that is now one pricey room. 194.58. Set. This next one, I think this is the 6th straight day we've looked at one of these, so I think we should be getting these down at this point. Okay, depth of the ocean the swim buoy reaches a maximum of 10 at 4 a.m. and a minimum of 2 at noon. Write a trig function that models the water depth as a function of time. Assume that t equals 0 represents 12 a.m. Okay, here we go. Numero uno. Find your midline. Find your k value. Max plus min divided by 2. 12 divided by 2 is 6. So what does that tell me? That tells me not only my midline or my k value, it also tells me where my first, third, and fifth points are. Once I have that, my only job left now is to figure out, okay, these other two are going to be my max and my min. So I go look, 4 a.m. and noon. Whichever time is closer to 12 a.m., 4 a.m., that's where my next one is going to be. So it says max is at 4 a.m. Max at 4 a.m., which means my minimum of 2, which goes here, is at noon, or 12 p.m. So graphically we're ready, and now I just follow my pattern. 12 to 4 is 4 hours. 4 to 8 a.m. would be 4 hours. If I've done it right, 8 plus 4 is 12 p.m. Good deal. And 4 more hours at the end. So I've got that ready to go. Next is my A value. We talked about going from the first to the second point. What direction am I going? How many am I going? I'm going up, and to get from 6 to 10 is 4. So my A value is 4. 2 down, 1 to go. Last part is to get my B. I have my period for 8, 12, 16 hours, but that's not my B. 2 pi over B is my formula, but I don't know B, but I know what the period is. We're going to cross multiply. We're going to scooch this over for a second here. And we're solving for B. So we divide by 16. And we're going to simplify this. Again, when you're simplifying, we're not putting pi in the calculator. Just the 2 over 16. Math enter to get me an 8. Gets me my B. And so now I've got all my values. A sine of BT plus K. Again, all of these, a lot of them have to do with patterns and just getting used to going step by step. And if you've been practicing these daily, as we've been doing all these, it should be clicking in pretty good by now. But if not, there's probably some of the questions we've done before that you might have kind of blown off that you go back and take a peek at. All right. Identify domain and range. I'm going to mention this again. I'll show it on the calculator as well in a minute. Whenever we're doing growth and decay, domain does not change. Range moves with an up or a down shift. So normally my range would be 0 to infinity, but it went down 4, so my range did the same. And we've also talked about how there's a direct connection between domain and range and my end behavior. My domain is my x values. So that sticks with those guys. My range, my y values, are my f of x values. Now, if here you're not quite sure which one would be which, I can understand where you might go to a calculator for a second on these. So we'll get this typed in. And we'll take a look at the picture. So I'll get to see there's my downshift of 4. So remember what this means. As x goes to negative infinity, as x goes to the left, so as we're going to the left, and I get closer to a y value of negative 4 or infinity, well, it looks like it's going up to me. But just to be sure, let's look at the other one. As x goes to positive infinity, as x goes to the right, what value is y approaching? It looks like it's flattening out by negative 4. That's how those go together. Lots of things that connect. But again, you got to see it to know it. If the minute hand of a clock is 6.5 inches long, how far did the end of the minute hand travel from 6 a.m. to 11 a.m.? Use the formula. Okay, here's the biggest thing here. This angle measure has to be in radians. It has to be in pi. My radius they gave to me right away. It's 6.5, so I don't have to worry about that part. I'm good. Here's what I've got to remember on this. When we think about a clock goes in a full circle, or 12 hours, okay? And a full circle is 360 degrees, or 2 pi. So how long is it between 6 and 11 a.m.? Well, this is 5 hours. So you're like, okay, so what does that mean to me? Well, I'm going to take 2 pi times 5 out of 12 hours. Because that's how much of this whole circle I'm going to need to figure out this angle measure. So I multiply across. Reduce my fraction, and you sort of start to see this pattern of, oh, we keep having to do this over and over. And you're right, you do. So you're like, am I done? Almost. So now to actually find how far it traveled, I'm going to multiply these two guys together. So 5 pi over 6 times 6.5. Usually, since it's an application, we will include pi this time, but if you didn't, if you said, hey, 5 times 6.5 is 32.5 pi over 6, if you left it that way, I would take that. Because, I mean, it's still the right answer. But if you go decimally, 17, I'll take either. But again, and I've said it time and time again, everything you do, show me. Because I get to take this little rubric and I get to give you points for all the things that you do right. So every single little thing I can do, I can keep grabbing things out. So we've got to make sure we do that. Told me how long the minute hand was. Yep, we're just stealing that for our radius. Identify zeros. X to the third plus 7x squared. Whoa. Try again. X to the third, come back down, plus 7x squared plus 4x minus 12. Okay, remember, when we're looking for zeros, okay, we'll pop the graph here for a second. Zeros mean x-intercepts. Now, if I look at my graph and I notice, hey, it looks like they're going across some whole numbers, instead of getting cute and trying to use the trace function, pull up the chart for a minute. So second in graph. And if you start to see zeros in the y column, those x values are your zeros. So in this case, -6, -2, sweet, and 1. Will they be that way on the post? Probably. So just kind of check them out and look in your chart and get that set. Oh, our other favorites. Factoring. Okay, 4 terms. We're going to pair them off. And then we're going to look in each pair to see what they have in common. 2 and 3, nothing in common. X cubed and x squared, we take the smaller exponent. X squared, to get to x to the third, I need an x, and there was no number, so I need my 2. X squared I've already got, I just need the 3. Now if I did this right, when I take my common factor out of the other side, I better have the same set of parentheses left over. 8 and 12, what goes in 8 and 12? 4. 4 times 2 gets me to 8. 4 times 3 gets me to 12. Sweet. Not quite done. The factored form will be your common set of parentheses and then the leftover stuff on the outside together. Got to get to that last step. And then we'll be good. Jenna was asked to show the complete factorization of the following polynomial. Jenna did this. Is it completely factored? Okay, easiest point on the entire exam. I'm not going to ask you a question and have it be perfect already. That'd be silly. So, no. If not, what's the complete factorization? It's our arch nemesis, people. What is this? X squared minus 16. A difference of squares. So whatever I square to get each part, don't leave it that way, though. Difference of squares is 2 sets of parentheses. Always has been, always will be. You've got the values that you need now in each one. And if I want to multiply to negative 16, I want one of each type. And that's it. Bless you. Simplify basically means factor, 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 cancel, cancel, cancel. So I start looking at these and I go, okay. First caution, that x and that 8 are bonded. Notice there's no parentheses here. It still doesn't mean in your mind there aren't. Okay, don't cancel those. Times the 4x minus 5 is up top. If I don't know, if I want to make it a fraction like the rest, I can put it over 1. And then now I got two things going on here. Divide means I'm flipping them. So the x plus 8's going to the top. I did it again. It's another difference of squares. Be ready, be ready, be ready. What do I square to get each part? 2 sets of parentheses with those values and a plus minus. And now, after all that, now I'm ready to start just zapping stuff. Zap, 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 zap. Let's see what we got left. We got 7x. We got 4x plus 5. These are bonded. Don't you dare cancel the x's after all that good work. And we're good to go. So lots of little things that we're taking into consideration here. Okay, 13, adding. I need an LCD. Just looking at denominators. I don't happen to have any coefficients. I don't happen to have any lonely single variables on the outside. It's just the 2 sets of parentheses. And we've talked about in some of these prior ones. That's good to get there. It doesn't mean now that I just leave these and say that it's x plus 3 over that. We're builders. How do I get from here to here? Whatever I got. If you don't get a check mark, you get put in. And I've got to do that for both. Check mark. Do it for that one. Again, at this point, I cannot cancel or I end up back where I started. Distribute your x. Distribute your 3. And if you happen to have like terms, get those together. Okay, we won't make it crazy complicated where you're going to factor again and cancel and stuff. There's too much going on for us to deal with that. So again, notice on 13 versus 14, like, man, you're going to make us do another one. No, I'm not. 13 I said add. 14 I said, what is the correct LCD? I just want the LCD. So, is the LCD for 14 x plus 6? No, I see an x there and an x there. Aren't they the same thing? No. Okay? Those are bonded. That's a single variable. That's a bonded one. I need both. Be careful. You're going to be trying to be set up that way. So we really, really, really got to watch for that. And then finally on this page 15, and I apologize for this, that's a 3. It kind of got smashed in there. So here, my job is to get to x. To get to x, I have log base 3 in the way. I need to exponentiate. Root word, exponent. 3 to the 4th power, not 3 times 4. 3 to the 4th power is 81. Add my 8 over. Okay, that's the only way you're getting there. No other sneaky way to get around it. You just got to do it, do it, do it. Get her done, get her done, get her done. Like, all right. Ooh, Harty. Ugh. Not really. Think about what we just did on 15. We had a log of a base. We exponentiated with that base value. basically I'm doing the same thing here, except now I'm going to use the log. And whatever we do to one side, we do to both when we're dealing in algebra problems. So those guys are going to cancel. Now this side, okay, here's where we need to have a quick discussion. I can't get that typed into my calculator, okay? I'm not going to go log 5, 625. That's not what this is. Wrong. What I have to do is I've got to do change a base, which is log of big, divided by log of little. And I'll get a nice number out, like 4. Okay? Log big divided by log little. And now we're in Algebra 1. Now I have no concerns at all. And if you went decimally on me there, I guess I could deal with that and survive. But we got to, again, keep those straight. And that's not something I will answer during the post. Yeah. What's that? Physical big. So always the number that's there already divided by the log of my base. Good question. 17. Again, don't solve this. What are the excluded values? Denominators only. Set them equal to 0 and find out what numbers there are. Because we don't want the denominator to equal 0. Well, the values that we're about to solve for will make the denominator 0. And that's what we do not want. And to be honest, I think the only thing that could get you on this is this very last part. When we take the square root to get rid of the squared means there's 2 answers. A plus and a minus. So we are going to have 2 excluded values if there's a quadratic. If I see a 2 here, it means there's 2 answers. And I've got to watch out for that. 18, another one we've seen a lot. Got to decide between 2 job offers. We already know where to go. Here's the 2 equations. So we know we got to get into y equals. And we need to carefully type these in. Because if we don't type them in right, it's kind of hard to get the right answer. Okay, double check. 800x plus 30,000. 20,000 times 1.06x. Yes. Chart it up. Okay, we need to start at 0. And I notice at the start, the blue column, which is Campco, is bigger. My job, when does the red column get to be larger? So I start to scroll. And I'm scrolling. Still scrolling. Oh, there it is. Okay, red column just got bigger. So we're in year 12. Now we've talked before about trying to make a determination with this. You got a long working career. Normally it's 30 or 40 years. I can see you arguing this either way. But you got to have a good argument. You could say, which offer's better? Well, Walby, after 12 years, the last 20 plus years of working, I make more. Because most of us are going to work 30 or 40 years. That's one route you could take. But some of you may say, man, 12 years is a long time I got to wait before I'm making more money. So maybe you go the other way and you go Campco. Maybe I change jobs or move in 12 years. Because the average person changes their job quite a few times during their career. Okay, it's rare that you work in one place forever. So I can take that argument either way, but just again, don't give me the, well, after 1 year it's 30,000, because we're not going to be job hoppers. That's not good for anybody. All right, you want to know how students and parents feel about start times for the school day? Determine whether the situation calls for a survey, observational study, or an experiment. Find those key words. Feel. Feel is a survey. Feel is an opinion. If I'm watching people, it's probably an observational study. If I'm doing things to people, putting them into groups by my own accord, then it's probably an experiment. Look for those key words. Almost there. For a stat project, a group of students decided to collect data in order to determine how healthy the average husky is in Harlem. They collected their data by interviewing all the students in the fit classes. Was this a good method of sampling for the average husky? Probably not. Okay, either what's wrong with it or what would you do? Why is it a bad idea? Okay, so fit students aren't the norm. So how can I fix my survey here? Okay. Instead, randomize PE students. Okay. That's legit. That's a good job of working that. Okay. Especially if you put both of them. Here's the problem, and then here's how I would come up with a solution. Not bad, not bad. Home stretch. All right, the infamous chart. Again, 3 different types, just like it has been on the other reviews. If I see and, or just a comma there, okay, 1 event. Overweight females. There's 21 out of the total. I don't know if that reduces or not. Whoops. Let's get out of there. Ooh, 3 out of 16. It does. Okay? Unless you see given, it's always going to be out of the total. Okay? Female or overweight. Means I'm taking total females, 50 out of 112. Overweight people, total, 66 out of 112. But then we're going to subtract the repeats. What do you mean by repeats? The overweight females, because right now they're being counted in both groups. So overweight females, there's 21 of them. I got to take them back out. So that would be 95 over 112. And I don't believe that is going to reduce anymore. Nope. And then our final option. Overweight given male. Magic word given. Whatever is after given is my denominator. Males. Which in this case would be 62. My sample set has shrunk. My numerator is both. Overweight males. 45. And that does not reduce. Got to look for those key words and key symbols to help me figure that out a bit. I'm going to go to 23 and come back to 22. Method to my madness, so stick with me. Okay, survey asked 40 people about current events. What's the probability a person gets the news from the newspaper given they are male? We talked about this yesterday. Don't look at theirs first. You do it first. Okay? We just got done with one of these. This is male. This is a fancy way of saying given. Male and newspaper goes on top. So I notice there's not totals. So I need to do that. 6, 9, 15, 20 total males. Okay. Males to get it from the newspaper. 5 out of 20, or 1/4. I did it right. I know I did it right. So I look at this other one. I'm like, okay, what did Jackie do? 5 out of 40. Where's she getting 40 from? So I start looking. 5, 8, 16, 20. Oh! She took the grand total. So Jackie probably did the probability of male and newspaper. Because remember, when we do and, like we did up above in 21, male newspaper would be 5, out of the grand total. Ooh, okay, that's what she was thinking. And I look at something like that. So back down to 22, and we've made it. Okay, we chatted about this before. We take our 3 types here. Comedies, 56 out of 120. Drama, we know nothing about drama. 80 out of 150. And sci-fi, 26 out of 60. We're looking for the 2 that are the biggest fractions. And if we're not sure on the fractions, we just go decimally. So 0.47, 0.53, 0.43. I want the ones that are the greatest number of viewers. I want the 2 biggest ones. I want comedy and drama. Okay, ladies and gents, this is your post. Okay, tomorrow we do the first, don't quote me, I think tomorrow's the first, I can't remember here. But it's short, okay, it's less than, it's about half. It's about 50-50, so you got plenty of time to get that done.